So since we won't have a lot of time in class, I wanted to give you a little overview of chemistry. This is information that you likely have had before, perhaps in high school or otherwise. So this quick material here will sort of give you just an overview of atoms and bonding in chemistry. So remember that in chemistry everything can be divided up into matter and energy. Matter is the stuff, and energy is putting that stuff into motion. Remember that matter is going to exist in different states and they can interchange. So a solid can become liquid, can become gas, etc. And all of that matter is composed of elements, which we'll talk about in a second. Energy, on the other hand, is the ability to do work. It does not contain mass. And there are two major types of energy. We have kinetic energy and we have potential energy. And so kinetic energy is kind of that energy of motion, and potential energy is stored. So for example, if you are chewing a protein bar, for example, you're using muscles to do that, and then the energy inside of that that energy inside of that protein bar is chemical energy, and that is going to get stored in your muscles, for example, or get stored in your cells, and then you can use it to do work later. So basically, energy is never created nor destroyed, but rather gets redistributed. Okay, so that's something to think about. I had mentioned on the previous slide that all matter is composed of elements, and elements are basically the smallest type, or the simplest form of a compound, the smallest type of a substance that can't be broken down, and it's only composed of one type of atom. And so what that means is that the element carbon is only made up of carbon atoms, oxygen is made up of oxygen atoms, etc. And there are 6 elements here that make up about 95 to 96% of all of our body weight in all living organisms, and primarily these first 4. These are kind of the most important, I would say, and we will talk about those in class as well. If you have extra time, there's kind of a fun song here. If you open this PowerPoint in slideshow mode and click on this song, it's pretty catchy. I will just give you that. So these are the most abundant elements in the body. And then trace elements are those that we still need, but not in as great of a percentage. And importantly, though, trace elements are still necessary for overall homeostasis. So for example, if you don't have enough iodine, you can have what's called a goiter, this sort of enlargement on the neck. Our salt is iodized, so we don't have to worry about that. But other types of elements that are important are going to be things like calcium, magnesium, sodium, potassium, phosphorus, and phosphorus is one of the major ones. But these, again, are quite necessary to our bodies, but are not part of those initial sort of 90 or 96%. These are all found on the periodic table of the elements. We're not going to go too much into the periodic table simply because this is not a chemistry class, but a couple of things to look at. There are different types of numbers here, so we'll have the chemical symbol, the atomic number, the atomic mass number, etc. And so if we take a look at basic atomic structure, remember that the atom is the smallest part of an element, and there's a nucleus, and then there are electrons that orbit that nucleus. So within the nucleus, remember, we have protons and neutrons, and the electrons orbit the nucleus and therefore can be shared or transferred because of that. And so remember that protons, what charge do those have? I hope you're thinking positive. Neutrons, remember, don't have a charge. And electrons have a negative charge. Whoops. So the electrons and protons are attracted to one another. And in normal elements, normal atoms, the number of protons equals the number of electrons, and so therefore you have a neutrally charged particle. So remember looking at the periodic table that there's going to be an atomic number and a mass number and a symbol, and the atomic number, so the atomic number, is equal to the number of protons, and then the atomic mass, or sometimes referred to as the mass number, is equal to the number of protons plus the number of neutrons. The number of electrons doesn't really fall into play because their mass is so small. So looking at this example, suppose an atom has an atomic number of 15, and if it has 7 neutrons, what is its atomic mass? Okay, it's kind of a strange element here if it really existed. So the atomic number is 15, which means it has 15 protons. So then what would its atomic mass be? Well, I hope you're thinking 22. Okay. Some other things that can happen, typically the number of protons is going to stay the same. The number of electrons might change, and then you have ions. But if the number of neutrons changes, then you have what's called an isotope. And isotopes typically are going to be heavier atoms or heavier elements because they have more neutrons. And so these can be radioactive. These can give off that decay, for example. And interestingly, radioactivity can be helpful, but it can also be harmful. Radioactivity is what can both cause and treat cancer, for example. So switching gears a little bit, again, those electrons are going to orbit the nucleus, so they're going to be hanging around the outside because they are attracted to the nucleus, which is positive. Now think about that for a minute. Why is the nucleus positive? Remember that the protons and neutrons are there, and the neutrons don't have a charge, so ultimately the nucleus has a positive charge. If you remember from chemistry as well, the electrons occupy the space in these different shells outside the nucleus, and the outermost shell is called the valence shell. And so those electrons are going to be interacting with other electrons on other atoms. And the innermost shell always has 2 electrons, but every other shell outside of that has to have 8 electrons in order to be stable. And so because of that, chemical reactions will occur when electrons in the valence shells are interacting. Okay, so I just wanted to give a quick note about that. I'll let you kind of read through this, but we can differentiate between a molecule and a compound as well. But if we look at those valence electrons, what happens is that if we have 2 types of elements here, let's say we have sodium and chloride. Well, sodium has 11 protons and therefore 11 electrons. So there's 2 here, there's 8 here, and then there's this lonely rider electron out here. Whereas chlorine has 17 protons, so it fills, and then it has an extra spot because there's only 7 valence electrons. So what happens is that in order to be stable, sodium wants to get rid of this electron because it's very reactive and it can cause problems, cause a lot of reactivity. So sodium is going to transfer its electron to chlorine, which wants to pick up an electron. Therefore, that's going to form an ionic bond, because then sodium will become a positively charged ion, and chlorine will become a negatively charged ion. And some names for those, if you remember, a positively charged ion is called a cation, and you can remember that because the T is like a positive sign. And the negatively charged is called an anion, negatively charged ion. Ions will dissociate in water, so if you think about salt, for example, different types of salts will fall apart in water. And with this slide and a couple other ones, I'm going through a little bit quickly just to give you kind of the main idea here. But if you look here, here's an example again of that sodium transferring its electron to chlorine to form an ionic bond again. So these are going to be ionic bonds to form ions. And then sodium, because it lost an electron, becomes positively charged. and chlorine becomes negatively charged. And then when you put it in water, for example, it's going to form these crystals, and those crystals will break apart. Other types of bonding is called a covalent bond, where instead of transferring the electrons, they are being shared. So co means to share. Whoops. Co means to share, and valent is referring to the valence electrons, so sharing valence electrons. And this is going to make a lot stronger bond than an ionic bond. And this can happen with 2 electrons being shared or 4 electrons being shared. And some different types of covalent bonds, they can either have sharing equally, which is going to be called a nonpolar bond. This is going to be something like fats, oils, for example. Some other examples here are some carbon hydrocarbons, so like methane and propane. And then polar covalent bonds, the electrons are still shared, but they're shared unequally, which means, for example, with water here, water is a polar bond. Water will form a positively charged end on one end and a negatively charged end on the other end. And we'll talk a little bit more about that in class when we talk about water. And then finally, a type of polar bond is a hydrogen bond. And this is not really a true bond, but it's basically an interaction between the negatively charged part of one molecule, like water, and the positively charged area of hydrogen. So some examples of where we find hydrogen bonds that we'll keep talking about are here. So between water molecules, between 2 amino acids to form what's called a peptide bond, and then between the strands of DNA.